Let's take a look now at combining all these transformations into one function. So obviously this can get a little bit big, but we have our steps, so we can figure this out. All right, so first off, we have to be able to describe transformation. So not only do we need to be able to graph it, but you need to be able to talk about what the transformations are. So here we have the function. It's our rational function, 1 over x. And we have g of x is equal to -3 bracket 1 over x plus 5 plus 4. So if I was looking at this, there's actually 4 different transformations that are going on. And remember, we're going to read things from left to right, starting with the negative sign. So that negative sign is in front of my function. So that means one of my first transformation that's happening is there is a reflection in the x axis. So that's my first transformation. And then from there, I see that I have a 3. And that 3, again, it's outside of my function. It's being multiplied to the whole function. So that is my vertical stretch. By a factor of 3. Now, if I keep moving on, the next thing I have is this plus 5. It's being added directly to the x variable, which means it's going to be moved 5 to the left. And then lastly, I have this plus 4 at the end. It's being added to the whole function, so it's going to be 4 up. So not only do you need to be able to graph it, but you also need to be able to talk about the transformations. Okay, so something like this has lots of transformations going on. You want to make sure that you talk about each and every one of them. Okay, so graphing method. We use a table of values. It's a convenient way to graph functions, especially when there's a whole bunch of transformations going on. Remember that we apply all our stretches, compressions, and reflections before we apply the translations. And one of the good ways to remember this is that we always go from left to right, dealing with every single translation that appears in that order. If you do that, then you will always make sure that you follow the rule of stretches and compressions and reflections before the translations, before left, right, up, and down. Okay, so here we have, I'm just going to move my graph over. Here we have a whole bunch of transformations happening to the square root graph. So let's start with actually our base function of the square root graph. So 0, 1, 4, 9, 16, 0, 1, 2, 3, and 4. Now again, we are going to read this from left to right, starting with the -2. So we actually, when we're using our table of values, can combine that, because instead of multiplying my y values by a -1 and then multiplying my y values by a +2, we can just combine that into one step. So we're going to multiply all our y values by -2. And when I do, I get 0, -2, -4, -6, and -8. Moving right along, next I have this x minus 3. It's all under the square root sign. So of course, this is going to mean it's moving 3 to the right. So I'm going to go over here to my x values and add 3. And when I do, I get 3, not a 0. Let's just erase that. When we do that, we get 3, 4, 7, 10, and 19. And last and not least, here we have this plus 5 at the end being added to the whole function. So I'm going to go over here to my y values, and I'm going to add 5 to each of these. I get 5, 3, 1, -1, and -3. So now what I'm looking at are these points, 3, 5, 4, 3, 7, 1, 10, -1, and 19, -3. Okay, let's plot these points. 3, 5, 4, 3, 7, 1, 10 comma negative 1. So it looks like this is what we have here. So it's been reflected into our x-axis. It's been vertically stretched by a factor of 2. It's been moved 3 to the right and 5 up. Okay, let's try another example. So here we have our absolute value graph. Absolute value. Again, we're going to start with our table of values. -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. Of course, absolute value means that everything that goes in comes out positive. Okay, so let's start with this negative sign. Okay, we're reading this way. This negative is outside my function, which means I'm going to multiply all my y values by -1. And I get -2, -1, 0, -1, -2. Next, I have this 1/2. It's on the inside. So inside means it's horizontal. Remember, it's always by a factor of 1 over 1 over 2. So 1 over 1 over 2, which equals out to 2. So this is going to be a horizontal stretch by a factor of 2, which means I'm going to multiply all my x values by 2. And I get -4, -2, 0, 2, and 4. And last, here I have this +3. It's being added to the whole function, which means I'm going to go to my y values and add 3. And I get 1, 2, 3, 2, and 1. And now I can list out my points. My points are going to be at -4, comma 1, -2, comma 2, 0, comma 3, 2, comma 2, and 4, comma 1. And let's see if we ended up with the absolute value graph. -4, +1, -2, +2, 0 and 3, 2 and 2, and 4 and 1. And look at this. Isn't this pretty? So we have reflected it in our x-axis, which is why it opens down. We've horizontally stretched it out. So if you want to think about putting kind of like grabbing the absolute value on either side and stretching it out across your x-axis, that's what we've done. And then we moved it up 3. Looking good. Let's try another example. Oh, baby, this one's big. So again, we're always going to read things from left to right. So, and we're looking at the square root graph. So let's start with the square root table of values. 0, 1, 4, 9, and 16. 0, 1, 2, 3, and 4. Okay, so we're going to begin here at 0.5. It's being multiplied to the whole function, which means it's going to be a vertical compression. And we're going to multiply every term by 0.5. So we get 0 times 0.5 is 0. 1 is going to be 0.5. 2 is going to be 1. 3 is going to be 1.5. And 4 is going to be 2. All right, and then I'm going to move across, and I see that I have this -2x plus 6 under the square root sign. I'm just going to take a minute here and rewrite this, because if you remember from the other day, when it's not written like that, x plus 6 is not written in brackets, we have to take the whole thing, put it equal to 0 in order to figure out what the horizontal translation is, but we can kind of cheat and by common factoring out the number in front. So if I common factor out the -2, I'm left with x minus 3. And the great thing is that I can now use that -2. I know that that is going to be a horizontal compression by a factor of 1/2. I can use that on my x values, and then I can see that this did not move 6 to the left. It actually moves 3 to the right. So important for us to take the time to common factor that under the brackets. So over here, remember it's 1 over the number that's being multiplied directly to the x. So we're going to multiply everything by a -1/2. Okay, not by -2, by -1/2. And that gives me 0, -1/2, negative 2, negative 4.5, and negative 8. Next, we have that plus or that minus 3 in the brackets, but when we bring it out of the brackets, it becomes a plus 3. So let's add 3 to all of these. So I get 3, 2.5, 1, negative 1.5, and negative 5. And then last, I have this negative 4 at the end. So that's being subtracted directly from the whole function. So let's subtract 4 from each of those y values. So negative 4, negative 3.5, negative 3, negative 2.5, and negative 2. Okay, so we have a great big table, but that's okay because we can still pull out our points. So 3 and negative 4, 2.5 and negative 3.5, 1 and negative 3, negative 1.5, negative 2.5, negative 5, and negative 2. All right, let's plot these points and see if we have a square root function. So 3 comma negative 4 is down here. And then 2.5 and negative 3.5 is right there. Should be kind of middle of the dot. And then 1 and negative 3. And then negative 1.5, negative 2.5. And negative 5 and negative 2. And let me just kind of take a look here. Oh, and look at that. We do have a square root graph. This square root graph has been reflected in our y-axis. It's been vertically compressed by a factor of 1/2. It's been horizontally compressed by a factor of 1/2. And it's been moved 3 to the right and 4 down. That's a great question. Lots going on there. Okay. Now, we don't always have a function. Sometimes we have some other kind of graph. So in this case, we have this square or diamond shape going on. What we want to do is we want to transform it with all these different transformations. So to start, though, I need my table of values. I'm actually just going to pull some points right off of this to help me along. So x and y. And negative 9, negative 3, negative 3, positive 2, positive 3, negative 3, and negative 3, and negative 8. Okay, so same thing. We're still reading left to right. I'm going to start with the 1/4. It's being multiplied directly to my function, which means it's a vertical compression by a factor of 1/4. So let's times this by 1/4. And when I do, I get negative 3/4. I get 1/2. And I get negative 3/4 again. And I get negative 2. All right. And then in here, I have x minus 5, which means 5 to the right. So I'm going to go over to my x values, and I'm going to add 5 to each of them. And I get negative 4, positive 2, 8, and positive 2. And then last, I have this plus 8 at the end. That's being added to the whole function. So let's go over here, and we're going to add 8. And I get 7.25, 8.5, 7.25, and 6. So I just converted those into decimals and then added 8 to them. Just makes it a little bit easier for me when I'm eyeballing where I'm going to put these points. All right, so my new points are going to be at negative 4, 7.25, 2 and 8.5, 8 and 7.25, and 2 and 6. Okay. All right, let's begin. So negative 4 and 7.25 is about here. And 2 and 8.5 is here. and 8 and 7.5 is here, and 2 and 6 is here. So we have really compressed this thing. So it's like we squished it. There we go. Look at that. So it's like we've taken our hands like top and bottom and pushed them down. All right, and then we move the whole thing 5 over to the right and 8 up. So it doesn't always have to be a function that we recognize. Of course, we can take any graph and transform it simply by creating our table of values and then following the transformations as they appear in our function. Okay, so here's a little table just to help you understand maybe what these functions can look like. G of x equals a f bracket k bracket x minus d bracket bracket plus c. So all this means, so if we look here, we have this a function that comes first, and of course that's right there. We're going to times by a. Then we have our k function next, but remember, I think we called it b in our notes, but it doesn't matter. It's just a variable. So when we have a number there, it's always multiplied by 1 over k. And then we have this negative d, and the negative d comes over here. Now it says minus d, but all that means is make sure that you change the sign. So if it was like a -2 inside, it becomes a +2 outside. And then last over here, we have our plus c, and it's at our y values. Okay, and then here's what all our functions could look like. So there's our cubic function, our square root function, our rational, and then our absolute value. So that's what they would look like if we applied all the transformations to them. You might want to take a minute, pause the video right here in order to get this copied down. And also, don't get hung up on the variables. I mean, I know that we kind of used a b, and we put the c inside the brackets and the d, but all it is just telling us that when you have those numbers in those locations, that's what we do with them. Okay, so an inquiry problem. This is a great problem. Feel free to pause the video here and give this one a try, and then come back. So if you're back, or maybe haven't even left, that's okay. We're going to start with f of x. I want to begin simply by looking at f of x. So f of x is that big function over there. So I want to create my table of values for that, noticing that this is absolute value. So -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. And I have all these different transformations that are happening. So I'm going to begin first with this negative sign that's outside of my function. So I'm going to times this by -1. And I get -2, -1, -1, -2. And then I see I have this x plus 3 on the inside, or x minus 3 on the inside. So that's going to become a plus 3 once I take it out. And that's going to give me 1, 2, 3, 4, and 5. And then lastly, I have this plus 4 at the end. So let me add 4. And I get 2, 3, 4, 3, and 2. So my table of values for that f of x function, if I just want to clean it up here, becomes this. I'm going to write it, instead of writing it as points, I'm going to write it as actual table of values. So 1 and 2, 2 and 3, 3 and 4, 4 and 3, and 5 and 2. All right, so that's what f of x is equal to. Well, now we want to look at g of x. And g of x tells me it's 2 times f of x plus 5 minus 1. Which means we want to go to our f of x table of values now, the one that we just did all the transformations on, this green one at the bottom. And now I want to apply all of these transformations to it. So let's start with the 2 out front. Remember, we read it this way. So we're going to multiply all of these by 2. That's a vertical stretch of a factor of 2. So 4, 6, 8, 6, and 4. And then we have x plus 5 inside our brackets, which means we're going to subtract 5 on the outside. -4, -3, -2, -1, and 0. And then last, we're subtracting 1 from our whole function. So let's subtract 1 from each of our y values, giving me 3, 5, 7, 5, and 3. And so the new points that I'm actually going to plot then, g of x is actually going to be equal to these coordinate points of -4 and 3, -3 and 5, -2 and 7, -1 and 5, and 0 and 3. So let's plot these and see what we get. It should be some kind of absolute value graph. So -4 and +3, -3 and +5, and then -2 and +7, and then -1 and +5, and 0 and 3. And here we go. Look at that. Now we have g of x, which was the big transformations of f of x, which had its own transformation. So we had to do 2 tables of values there in order to get our final result of g of x. So that is a fantastic equation. Great example. Okay, so the best way of doing this stuff is to practice it, as always. So if you go into your textbook on page 129, there are some questions for you to try. Again, as always, if you need any help, please reach out.